Okay, so welcome back. And now we're going to talk about is eliciting requirements. So last time we talked about what a requirement is, and we talked about the different granularities, and we talked about the different types. So granularities are high and low level requirements, types are functional versus non-functional requirements. It's definitely something that you should be prepared for on the quiz or the tests. There's knowing the difference between these things. We also talked about the fact that eliciting requirements or gathering requirements from a client is extremely non-trivial because the client often will not give you all of the requirements through omission, by complete accident in most cases, and the requirements that they give you may not be super clear. And so it's kind of on you to make sure that you understand what the requirements mean and that you have a good idea of what the requirements of the system are. So what we're going to do is we're going to talk about why the process is hard a little bit, and then we're also going to talk about things that you can do to actually make it a little bit easier. So at the core of it, there are really two sides of every project. And I'm going to use these terms throughout the semester to kind of indicate what the members of each of those two sides are. And this isn't really a conflict situation so much. These aren't adversarial teams or anything like that. It's really just to denote membership in an organization. And so the business team, these are people who are working with the client. And they understand what the system should actually be doing. A lot of the times people on this team are people who will actually end up using the system to begin with. And so they have a lot of information about these requirements that you're trying to gather, and they are the people you're trying to gather requirements from. And so they're called the business team because they understand the business. On the other side, there is the development team. And the development team understands how to build a piece of software. They're the software engineers, they're the architects, they're the project managers who understand the technology, and it's their job to go to the business team and understand what it is the system is supposed to be doing, how it's supposed to be doing it, and then kind of catalog all the requirements that the system has to make sure that the business team is going to be able to do their job after the project is complete. So another kind of vocabulary word here is people on the business team are often referred to as project stakeholders, and each stakeholder might have a different stake in a different part of the system. And so we're going to talk about how systems are decomposed into modules or they're decomposed into units. And although a stakeholder may have a lot of stake in the mortgage aspect of a banking application, they don't necessarily have a stake in the savings or the brokerage part of the banking system. And so you might have many different stakeholders, and all of those stakeholders together will have a sort of common voice, hopefully, about what the system should be doing. And so the biggest challenge, the thing that makes software engineering very different from kind of development that you might do on the side, or even development that you might do as an open source engineer or something like that, is you have these two very clearly defined teams, and in a lot of ways they have drastically different education, they have drastically different things that they want to get out of the project, and you have to synchronize not only their communication but also their understanding. And so the business team and the development team, although they went to very different programs in school, they have to understand, you can imagine kind of a Venn diagram. We have to develop that intersection where a person on the development team or a person on the business team can look at a requirement and say, yes, I understand exactly what this means. And from the business team, they would understand how to actually use that in their daily life, and the development team would understand how to actually implement that functionality. So the textbook in the class is optional, and one of the things that the textbook does really well is covering what are called application domains. But I want to back up just a little bit and talk about what I'm referring to here as institutional knowledge. So as you become better and better at software engineering, you're going to find that you also become better and better at using the specific platforms and the specific frameworks and the specific processes that your company uses. So once you go from your first software engineering job to your second, to your third, to your fourth, what you're going to recognize is that each of those have maybe 85% overlap in terms of best practices for coding, or for checking in code, or for merging, and they have largely the same ideas around things like requirements gathering and what's important from a process perspective. What they may miss, or they may have differences on, are how they put all of those things together, functionally, how they go out and gather requirements, what types of systems they build, or what types of systems they use to build software. All of the information in that 15 or 20% that is specific to your software engineering firm is what's referred to as institutional knowledge. This is stuff that you just gather over time. It's experience. It's just kind of day-to-day information that's very, very hard to write down. So one of the things that we do at my company is we go in and we try to assist with IT departments and failing insurance companies. And so one of the things that we do is we sit down with people in the IT team and we say, hey, can you take this piece of paper and write down all of the things that you do every day and give me all of the institutional knowledge in your brain just by virtue of writing it on a piece of paper. And that is almost impossible. And if you think about you yourself, even as a student, right? If somebody came to you and asked you to write down everything that you've learned about student life at FSU, or everything that has made you a successful student in your time at the university, if you were asked to write that down on a piece of paper, you would undoubtedly forget something. You would forget something, or it would be incomplete in some other way. You would have mistaken a detail or something like that. It's no different than a person at a client trying to tell you exactly all the requirements that a banking system has to have. And so this institutional knowledge kind of goes above and beyond all of the stuff that you were taught in finance school if you're working for a bank. It is all of the kind of nooks and crannies of the business. It's all the stuff that doesn't work particularly well at your bank. It's the fact that in order to make the coffee pot on the second floor work, you have to kick it 3 times and then wait 15 minutes, and then suddenly it magically works. So this institutional knowledge is, in a lot of ways, the most important thing that an organization has. If you try to replace a whole bunch of people on a team, if it's the business team or if it's the development team, it doesn't actually matter. If you try to replace them with people with the same skill set, you're still going to have problems because you're going to have lost some of that institutional knowledge. It's impossible to write down. Institutional knowledge on the development team, that's a thing that we're going to talk about later in the semester. But institutional knowledge on the business team is really, really difficult to replace if it is lost. And it exists in what's called an application domain, which is the business context in which the application is actually supposed to operate. And so if you think about bank, the application domain of banks has all sorts of ideas and terminology and components to it that you as a software engineer have potentially no idea how it works. And there's a whole bunch of stuff that you can write down, right? You can go and you can look at a whole bunch of finance books and kind of suss out some of the details. But what you're never going to be able to get is the institutional knowledge for the specific client that you're working with. So application domains themselves are really important because they kind of segment applications into these very specific types of applications. There are banking systems, and there are word processors, and there are insurance websites, and there are law websites, and whatever. And it gives you an idea of things that worked for one bank could potentially work for another bank. But what application domains in general miss is that if you take the Bank of America system and you give it to Wells Fargo, it isn't going to 100% work. And the reason is because the institutional knowledge for working at Wells Fargo is fundamentally different than the institutional knowledge for working at Bank of America. And so, yeah, you could absolutely sell Bank of America a banking system that was created for Wells Fargo, but you recognize that there's always going to be potentially a double-digit percentage of the code or the system itself that is just not going to work the way they expect, and there's going to have to be some work there. So some example application domains that are kind of easy to wrap your head around are things like banking. They're things like the legal industry, insurance, education, even very specific things like space flight or like automated cars. These things have, again, various levels of abstraction. So inside of banking, you could have banks that are really geared toward mortgages. You could have banks that are really geared toward investing, so on and so forth. And as you talk to one client, the best thing that you can do is think about the smallest application domain possible for that client, so that you're not trying to understand a whole bunch of different stuff that doesn't necessarily relate to the project that you're trying to actually do. So the very first hurdle that you're going to have trying to understand the requirements of a system is understanding what the system is supposed to be doing. And so the example that I use kind of semester after semester is if you don't know how mortgages work and you don't have a clue that banking applications should support a mortgage, there is effectively a 0% chance that you're going to read the list of requirements, identify the fact that mortgages are missing from the list of requirements, and then go back to the client and say, hey, you forgot to talk about mortgages. And what this does is it opens the development team up to risks of what are called omission. So if the bank forgets to put the stakeholder for mortgages on their business team, then potentially you could go through an entire project and you can have a project that is very good at investments and at account management and at money markets and all these kinds of various things, but it could fundamentally just not have information about mortgages in it, which would be very, very bad, because when they go from their old system that does support mortgages to their new system that now suddenly doesn't, now an entire arm of the bank doesn't have a system to support them. So this is obviously a very bad situation. And so going back to these initial kind of client requests, if a bank comes and asks you to build a banking application, from their perspective, they know mortgages are a common thing that happens at every bank. And they might assume that you will know that this is a common thing that happens at every bank. But if you don't know that, and they don't know that you don't know that, what ends up happening is everybody starts making assumptions. And then at the end of the day, people are very upset that the system doesn't do all the things that it's supposed to do. And again, this is kind of a cooked up example, but you can kind of see this happening, right? It's kind of a thing that makes sense, but it isn't necessarily something that's transparent at first blush. So if you tried to understand the application domain completely, that's a little bit untenable. So basically what you would be doing is you would say every software engineer on the development team now has to go get a degree in finance. And some of you have to become CPAs, and some of you have to become licensed mortgage brokers, and some of you have to pass the Series 7. And the reason is because we have to build this banking application. And so what you've done is you've taken on years and years and years and years and years of training, and it's just kind of a hilarious situation that you've put yourself in, trying to fully understand the application domain, when really what you need to do is let the business team guide that part of the project. So it's best to kind of be hands-off in terms of what the application should actually do, and focus on your area of expertise, which is designing and implementing software. So What you want to do is, instead of understanding what the application domain is, you should be able to protect the project from unknowns caused by your lack of understanding. And so things that you can do in order to make that true. You can make sure that the client understands that if a requirement is left off the list, that's a them problem and not a you problem. So you protect yourself from omission by saying it's not on us to go back to you and ask if you're really sure, is this your final answer, when you give us a complete list of requirements. You can also ask as many "are you sure" questions as possible, and you can also ask as many clarification questions as you possibly can, and often being as pedantic as possible, particularly toward the beginning of a project, is very good and is very to your benefit. It all kind of goes back to scope, right? If you have been very clear about what is in and out of scope, when they recognize, hey, mortgages aren't in this project scope at all, it is very obviously not a you problem, it's a them, it's an oversight on their part. And so what can happen is hopefully they will go back and get new budget or new resources for including that line item before they start using your product and miss out on a whole piece of the business. So the part that's very difficult is that the members of the business team, what they're really responsible for doing is giving you just enough information about the business for you to be effective. And so that really boils down to an ad hoc education. And so you can think of this as take your kid to school or take your kid to work day 10 or 15 years ago or 20 years ago for me, where you would kind of follow your parent around and understand what it was like to work in whatever company. They kind of have to take you along for the duration of the project, right? They have to explain exactly what each requirement does, why it does it, and it's important to know the why, because if you don't understand how all of the pieces of the system tie together, it's very easy to miss key kind of relationships and have holes in the system where it doesn't kind of make sense. So it's also true that the members of the business team will also have some familiarity with technology. And so this is increasingly true as people become more and more interested in technology in a general sense, and technology becomes easier and easier to acquire. You're going to run into clients that have various levels of expertise as hobbyists even in software development or what they think is software development. And so again, this is kind of a continuum of experience, but at either end, you're going to run into some struggles with clients that you kind of need to be prepared for. So on one end, you can have really non-technical stakeholders, and what's going to happen here is they're going to struggle with vocabulary, they're going to struggle with jargon, they're not even really going to understand what is and is not possible in a lot of ways with technology. On the other side, you're going to have extremely technical stakeholders that have done things like use Google services, and they will struggle, A, with letting the development team take the lead on development, and B, they will struggle with the length of time that it actually takes to generate production software. So they will take the niche sort of requirements that they've given your team, and they will compare your team of 3 or 4 or 5 engineers to Google's team of hundreds and hundreds and hundreds of engineers, and they will say things like, oh, well, you couldn't get our dialog box to work correctly in 2 days, and Google can blah, 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 blah. And you're going to constantly have to kind of level set with the client that Google has way more resources than you probably have unless you're working at Google. And it's often not an apples and apples comparison if you're trying to compare something that a very large sort of mega corporation is doing with what a smaller team of developers is trying to accomplish. So I'm actually going to give you two anecdotes here, but the anecdotes in the slides is I was once on a project where where this law firm is taking a terabyte of case management data. So this is basically all of the different cases they had been working on from, I think it was around 2012 or 2013. So 1975 all the way through 2013, they were trying to take all of that information from a file-based or a file system-based system and put it into a relational database. And so I had spent a fairly long period of time trying to map out exactly what tables and what columns each of these pieces of data would ultimately be moved into. So from essentially text files into a relational database. And at the end of one of the meetings, I asked for access to the database file. It's fairly early on to kind of get access to what they were calling a database file, which is basically a bunch of pointers to specific files. And the person that I was talking to literally got up from the table and sort of left the room. And then after a long period of time, they came back, and what I found out they were doing is they were actually rummaging through filing cabinets because they were under the impression that we were taking physical files from a physical filing cabinet and actually putting them into a database, when actually their system was already on like a digital file system. They just needed to be moved from a digital file system to a relational database. I've also been in meetings with clients where the client will want to do things like run code on a laptop that is powered down, for example. So in their mind, right, these things kind of happen all the time. Technology is magical, and the sort of details of the technology are irrelevant. And so you could run into situations where a client may want something to happen on a laptop that doesn't have batteries, for example. And so it's easy for them to think that something like that is possible, but it's very hard for you to explain why it's not possible. And when you try to do that, potentially you'll get a whole bunch of stories of amazing technology that's been done elsewhere. And it's difficult to not react in a knee-jerk kind of way to that pushback. Then you kind of have to understand how to just sort of take it for what it is, and kind of turn the discussion to something more reasonable. So when you're working with clients that are fairly non-technical, one of the things that seems hilarious but actually turns out to be fairly helpful is building a literal dictionary of terms that you can use for them to reference during a call. And a lot of the times this helps minimize confusion. So this can be something as simple as a dictionary that tells them the difference between a feature request and a bug. It could also be a dictionary that helps your side, the development side, understand that the client calls a bank account a widget, a whatever. And so it helps kind of get everybody talking the same language. And as they're talking the same language, everything becomes smoother. And so as you go through meetings where everybody's using the same vocabulary, everybody kind of gets on the same page, and it almost becomes a sort of gathering of the two teams, and it becomes much less adversarial because of the same words being used. It's also extremely helpful for cutting down confusion during calls. So I've actually been on multi-hour calls about planning other calls. And what you find out very early is that time is money. And basically, if you spend your entire 8-hour day meeting about a project, you have very little time to actually accomplish anything on the project. And so if you can provide to them any sort of written resources that let them minimize confusion, that's going to ultimately translate to fewer overages caused by time spent rehashing and rehashing and rehashing something as simple as vocabulary words, or something as not simple as specific issues that need to be explained. And it also is very, very helpful to use the words that the client is using in the meetings in the actual design and development of the system. So there is terminology that is used in the application domain that is often drastically different from what is used in sort of common vernacular. And so in the legal industry, for example, you might think of a sort of case in a court as a case, but law firms often refer to these things as matters. And so if you use a case that is a slightly different thing than the metadata that they're using to store about a matter. And so this is often referred to as the design metaphor. So as close as you can get the design metaphor to what is actually happening and what the end user experiences day to day, the better your situation will be. And so words really, really matter a lot, even though it seems kind of hilarious. And anything that you can do to make the words the same between the development team and the business team, and even embedding those words in the actual implementation of the system, the easier your entire life will kind of end up being. So on the flip side of the coin, you can also have people who are extremely versed in technology. And so we work a lot on website development. And in a lot of cases, that website development stops being website development and starts being web application development at some point in the project. And so many of you may know websites are sort of a Wix situation. It's sort of static content. Web applications are much more dynamic. They require logins. They do lots of integration with various third-party APIs. And the effort estimation, or the amount of effort required to do each of these things, is drastically different. And so technical clients can sometimes miss that because they are so interested in technology that seems so much more difficult than just building a web app, that they trivialize a lot of the work in their head. And so we have a particular client who is apt to kind of get in the weeds and think about a lot of technical detail and the relative merits of kind of all of the implementation details. And it translates to a non-trivial amount of time. Kind of documenting different techniques, giving comparisons of those techniques, and trying to not even provide best practices, but kind of prove why practices are best practices. And all of that time either is ultimately going to be billed back to the client, which is going to make them angry, or is going to be just kind of written off, and it's going to be time that you could have otherwise spent actually doing this sort of stuff that was requested of you. So the really important thing here is to set boundaries. Most of the time, these clients are not trying to do anything untoward. There's very few times where there's actual ill intent between a client and you, the firm, trying to help them. Most of the time, it's very much a matter of being excited or being interested in the things that you're trying to do. So the most important thing that particularly a project manager can do in one of these projects is to set boundaries and basically say, this is a technology component of the system, not necessarily a business component of the system. We're happy to provide you kind of the menu. Here are the 4 or 5 different options, and you can pick one of them. But ultimately, we are the ones who gatekeep the technology content. You can make the decisions if you want to, but there is a separation of concerns between the people who understand the business and the people who understand the technology. And if you understand the technology more than we do, client and development team, then potentially you should take on the work yourself because you're not getting value add from including us on the project. So for any project to be successful, particularly a software project, what you really want is you want a certain mutual trust level. And so what you need is for the client to understand that you are acting in their best interest. And so you have to actually act in their best interest. And you have to remind them things like any research that we do in order to answer a question that you have is going to be work that we could have otherwise spent actually trying to build the functionality that you want to build. And when you receive technical pushback, well, why aren't you doing it this way, that kind of stuff, what you need to do is very clearly and concisely set expectations for time spent trying to rework stuff and time spent trying to document why you're doing each individual step along the way. So one of the things that you have to do throughout the implementation and sort of design of the project is you have to document all of that stuff. If the client wants you to document specific sort of decisions at every step, that's certainly a thing that can be done, but obviously it's going to increase the amount of time it takes to do any of those tasks. And so you have to be very transparent about times where the client is maybe not acting in their own best interest, trying to spend time that is going to provide potentially very low return on investment. And ultimately, software engineering is a business. And if you go back to the client and you do hours and hours and dozens of hours and weeks and months and years of research and you don't bill them for it, the client is always going to accept free work. That's just kind of the way, that's the nature of everything. And it's okay to provide some free work if it is goodwill, right? So if they ask a genuine question and you're going out and you are truly trying to make sure that you're doing the best that you can, that's great. However, if you are doing that to a fault, if you're doing so much free research that you're not actually doing any work on the project, they're going to recognize that very little sort of work is being done and very little progress is being made. And they're not going to necessarily recognize that it's because of the amount of research that you're doing or because of the amount of kind of documentation that you're doing for them. So it's really important to be transparent about those things. They will accept tons of free work, but they're less apt to do that if they recognize that it is hindering their own sort of timeline for development. So we've kind of talked about both sides of the coins. We've talked about kind of the two natures of clients. There's obviously a whole bunch of different clients in the middle, and so it's important to kind of think about what the client is, like what type of client you're dealing with, so that you can deal with them in a way that is in their best interest and also your best interest. But we haven't necessarily talked about like the physical way in which you deal with clients. And the most common of those is a team meeting. And so these very frequently happen multiple times a week during the first parts of a project. And then they kind of taper off to maybe weekly or bi-weekly near the end of a project. But team meetings are basically between both the business and the development teams. They don't necessarily contain every person on each of those teams. But the idea is you want to establish a working relationship between the two teams, and you want that working relationship to be mutually respectful and mutually trustworthy. And you want to be able to perform some level of requirements gathering in those meetings so that everybody is kind of on the same page. So we also talked last week about how if you have Scrum meetings every day, but if you have Scrum meetings 4 times a day, yeah, it's great for communication, and yes, it's great for team building, but it's not necessarily great organizationally. And if you have 5 meetings a week with a client, they can't do their job, you can't do your job, everybody starts to be kind of agitated by the situation, and the result is a lot of really severe problems. People stop showing up to meetings, people stop being able to do their job because they're too busy meeting, so on and so forth. So very often, both of these teams have a project manager. The job of the project manager is taking charge of scheduling the meeting, making sure that they are a reasonable length, keeping up with the agenda for those meetings, and making sure that any discussion that happens in the meeting is worthwhile, that you're not just basically having a 4-hour meeting for the purposes of having a 4-hour meeting. You're actually contributing something to the project, or there's some sort of work being done as a result of that meeting. So one of the key things that you want to do during these team meetings is talk to the development or talk to the business team as a development team to understand what the critical business processes are that your system has to actually perform. And so, for example, now we've been talking about a banking system. That banking system may need to allow a user to add a new account or change their password. It may also require them to enter certain information to set up a brokerage account or do day trading. They also have mortgage applications and that sort of thing. And within each of these areas or units or modules of the system, there are going to be very specific processes that both the people on the business team can do and end users of the system can do. And so these are things like creating the actual account, depositing money into an account, making payments on a mortgage, et cetera, et cetera. And so general meetings are really, really good for identifying these kind of larger groups of things. And so they're really good for identifying which stakeholders are interested in which parts of the system and maybe less interested and more responsible for different types or parts of the system. And so then what you can do is you can take and create a meeting for each of these teams and meet in a sort of smaller context for a longer period of time, trying to get requirements for each of these kind of use cases that they're discussing as business processes. One of the ways that you can kind of gather requirements is by literally doing interviews with the people kind of on the ground at the client doing these business processes. And so there are two types. One of them is a structured interview that actually has specific questions that are set out to be asked by the person on the development team trying to get information. There are also unstructured interviews that are way closer to a sort of conversation. They're less a questionnaire and more a conversation about how the person does their job, and it allows the interviewer to be kind of dynamic. If they recognize that the person is kind of giving flippant answers that aren't actually going to help them, they can turn and kind of shift gears to something that the interviewee is more interested in, kind of get them more interested in providing better quality information. So the one thing about interviews is that it's really, really important to talk to multiple people that perform the same process, because even if there are only a finite number of ways to add money to an account, you can guarantee that people at the bank each have their own different way of doing it. And what you want to do is make sure that your new system is going to support as closely as possible all of the different ways that a user interacts with the system. And you also want to make sure that you're aware of all of the things that various people don't like about the existing system, so that you can make everybody as happy as you possibly can. So there are tons of alternatives. So these things are potentially more invasive. So things like we were talking about job shadowing. So basically just going around and recording a person doing their job. They can do this with like a voice recorder. You could also video them doing their jobs. There are also questionnaires that you can have people fill out online, and then you can kind of dig through their responses to questions. You can also go to an application in the same application domain. So if you're trying to build the next great budgeting application, you could go to Mint and sort of understand the different types of features and functionality that they have. You could potentially use the application yourself, and then understand what you would do to make it better, and then use that as an idea factory for requirements gathering. So in the absolute worst case scenario, you don't have access to the experts because they are too busy, or because they left the company or whatever, and you don't necessarily have the institutional knowledge that you need in the application domain. So what you have to do you have to go through and kind of understand manually what the current process or the current system does, and you have to accept the fact that if you don't have access to do interviews or ask questions to the end users, you're going to be more error prone, and you're going to have more sort of cognitive dissonance around your application than you would otherwise. The core of requirements gathering for it to be successful is client motivation. So if you want to be very, very good at requirements gathering, you kind of have to understand why they want the system to be created in the first place. So if they have an existing system and they all think the existing system sucks, why do they think that? Is it that it's very hard to use? Is it that it doesn't exist on the internet and they have to come into their office to use it? You need to understand what is broken so that you can fix it in the new system. Or do they have a manual process and they're trying to automate it? And in that case, you want to maximize the number of things that you can automate. You want to make sure that you're not just digitizing a manual process so that they have to do the same level of work, because that level of work is clearly what they're trying to get away from to begin with. And another thing you need to watch out for is if what I'm calling frontline workers, so the tellers of the bank, if they have a very different story than, say, the manager of the bank, you need to make sure that you're accounting for all of these different people's opinions. And so if the manager thinks everything's great, it might be because the tellers are scared to tell them that it's not great. But this is an opportunity for you as a software vendor or as a software organization to help make everybody's life easier and kind of get everybody on the same page. And so this is kind of a value add situation that you can bring to the project. So a very useful way of understanding requirements themselves is as interactions between the user. So that could be an end user that's actually a client of the bank, or a person on the business team, an actual sort of just regular user trying to use the system to support their job. So what use cases do is they capture individual business processes, recognizing that usually there's a one-to-one relationship between user interactions and the processes that are actually taking place. When there's not, it's often because a process is automated and the user doesn't actually have to do anything, and so you have to make sure to be wary of those as well. But as long as you can gather a fairly complete list of use cases, that's a very good starting point for requirements gathering. So there are use case diagrams that visually represent the relationships in the system. And again, this sort of visual information helps to minimize misunderstandings, because you could talk about something a lot and still have two people not understand what each other are saying. But if you talk about it in a meeting, you have it written down, and you have a visual representation, it's much less likely that the people are on different pages. I've included a link to a website that gives you a ton of information about use case diagrams, what a use case is, and all of the different sort of things that you can incorporate in use case diagrams. Again, this is kind of an item that exists on a continuum. You have very, very detailed use case diagrams, that you also have kind of abstract use case diagrams. And really, as a software organization, it's up to you to determine the use case or the specific use case diagrams that you need to provide for the specific project that you're working on. What I want to do is take some of the content from this reference or this resource and kind of talk about those specifically. So if you're looking at a use case diagram, the kind of most simplified form is talking about how the end user on the left, so Mr. Stick Dude here, is actually interacting with a library system in this case. And so this representation here says, if I'm an end user, I should be able to go to the library's website and actually borrow a book. Okay, that's pretty straightforward. You would have use case diagrams for each of these use cases. I need to be able to return a book. I need to be able to do various things, sign up for reading time for my kid or whatever. You also have extensions. So these are things that allow you to have more robust relationships between sort of the function that needs to be present for the end user and all of the different checks that need to happen to ensure that the use case is actually supported correctly. And so I moved myself out of the way. What we have here is we have to be able to borrow a book, but potentially I don't want people to borrow a book if they have a whole bunch of outstanding fines, and I obviously can't let them borrow a book if I don't have the book to begin with. And so here what they're saying is they should be able to borrow a book, but before we let them do that, we should first check availability, and we should also check to see if they have any fines. So then we can also have extensions. So here what we're saying is we should be able to borrow a book, but potentially that person isn't going to necessarily know what they want to borrow to begin with. They want to be able to browse, they want to be able to search by author, they want to be able to do all of these different things that let them hone in on a specific book that they want to borrow from the library. And so just like we had an includes relationship, we can also have an extends relationship where borrow book calls out to a book search or a book browse feature that allows them to find the book that they want to actually take from the library. So use cases are really, really good at telling you what the system should actually be doing. They are not very good at telling you how the system should accomplish what it is you're trying to accomplish. And so you can see things like a user needs to log into the website in order to see their member information. So for our library example, you want the user to have to log in order to see the fines that they have associated with their account. But it is kind of unclear from that requirement or from that use case what that experience is actually like. So is there two-factor authentication? Is there a requirement for passwords? Is there a security question that's required? Is there a PIN that's required? And what you find is even though you could have include statements that include a lot of this functionality, what you don't necessarily have is the visual. You don't have the picture. So is this just a username and a password box, or do they have to verify some image like you have to do when you go in to check your financial aid, that kind of thing. So this shows you the tie that exists between the requirements of a system and what the system itself actually looks like. And so we've talked about how software engineering is difficult because it requires people to be things that they aren't necessarily trained to be. And so we've already talked about how you kind of have to be a project manager if you don't have a dedicated project manager. We've talked about how you have to kind of be the client's therapist in order to pull out all of the information that they have about the system and why they don't like the system and how they do their job and etc. And you also kind of have to be a graphic designer in some cases, right? So if you don't have a dedicated resource for UI development, software engineers are kind of required to come up with the best estimate of what a UI should be. This class is going to show you that on the group project in a very real way. So the graphic designer is a particularly tough spot to be put in if you don't necessarily have any interest in it, you don't have any talent in it, it's not necessarily a thing that you care so much about. So what we find is that use cases themselves leave a lot to the imagination. So you don't necessarily want that situation because you don't want to be making decisions about what the system should look like on behalf of the client. I'm actually going to move myself up here. This brings us to wireframes. So wireframes are really, really important because what you're trying to do is you're trying to get as much information as possible so you can synthesize that into a specifications document. And what wireframes do is they give you the same ability to do this kind of rapid iterative refinement on what the UI should look like. So what you do is you go to the client with a very rudimentary sort of like sketched out boxes and labels kind of look, and then you get their thumbs up and thumbs down before maybe you contract with the UI developer or you get your UI expert to spend time trying to build an actual UI. So You can have situations where you're going to have wireframes that are professionally created. They are beautiful. They are exactly the sort of detail that you would have in a production site. This often happens if you're trying to do a call for proposals for a government website or something like that, if you're trying to pull down a really big contract. But it could just as well be squares drawn in Microsoft Paint. It could be something extremely rudimentary because the point is really rapid prototyping. What you're trying to do is get something in front of the client that they can say yay or nay about as quickly as possible so that you're not using resources that you could otherwise use actually building the website or the product. So rapid development is becoming a thing that is way easier to do now than it ever has been before, largely because we have so many libraries now that support it. And so if you think about something like HTML5, it's really, really easy to put a UI together in HTML5 compared to something like ASP.NET or compared to the various sort of WYSIWYG things that have been done in the past, and also way easier to do prior to having sort of even WYSIWYG tools available. And so what you have is a situation where an HTML5 page can serve as the mockup that you just kind of cram fake data into, but it's also the first step toward the full page. So if you're using something like Angular or you're using something like React, you can just take the same HTML and basically copy and paste all the components that you need into the actual project when you're actually creating the site or the product. So there are tons of languages, there are tons of frameworks that support this, and that isn't necessarily their core goal, right? Their core goal is to make development easier, but by virtue of making development easier, they make rapid development easier. And so we're going to talk about fourth generation languages when we talk about architecture, but if you think of trying to prototype an application in something like Python, it is way easier than trying to prototype an application in something like COBOL. So even though we don't necessarily recognize these technological advances as things specifically for rapid development, they kind of are better for rapid development just by nature of what they are. So to wrap up this part, and this is kind of the meat of the module, we have identified the fact that the business team is the set of experts about what the application should do. They're the bankers, they're the tellers, they're the lawyers, they're the people who use the system day in and day out, and they can tell you when something is wrong, why it's wrong, how it should be changed, and how it should be designed to begin with. The development team is a group of experts about how applications should be developed. So that's the software team that you will be a part of. They are software architects, they are designers, they are the people who understand the technology that is needed to implement the code, and they lean on the business team to understand the application domain that they're working in. So we've also covered the fact that clients often don't know what they want and they don't know what they need, and they really kind of need assistance trying to understand what a complete list of requirements looks like in a lot of cases, and this requires the development team to ask good questions and foster a good relationship with the client, and all of that is kind of predicated on trust. If they trust you, they will listen to your questions, they will provide you feedback, and the project will go way better than otherwise. We've also talked about use cases and wireframes as two ways of kind of formalizing information in requirements. And both use case diagrams and wireframes give you a kind of visual representation of a requirement that is very helpful when trying to make sure that everybody's on the same page. And it cuts down on cross-team confusion where the business team expects one thing and the development team is building something else. So the next video, the kind of last lecture for this module, we're going to very quickly discuss what the metrics are for success and metrics to be wary of throughout the process of actually trying to gather requirements. And we're going to talk about how you can use those metrics to mitigate risk that arises during the requirements gathering phase, recognizing that a majority of risk can be identified at requirements if you're gathering requirements kind of in a reasonable fashion. So that wraps it up for this lecture. Thanks for tuning in. I hope to see you in the next one. And as always, please let me know if you have any questions, comments, concerns. I'm happy to help you with any of those. Thank you very much.